Hello again, my friends. Welcome once more back to the cellar. Yeah, today I've been doing a lot of work on the station. I've been doing a lot of work on the turntable. Forgetting about that until the motor driver turns up, which still hasn't arrived. Expected sometime this week. What I'm going to do today is catch up on a couple of jobs, well, one specifically, that has been outstanding for a while. This board here, this is board I. This is my reversing loops. The reversing hardware is all on this side, so these are just wired normally. JMRI doesn't know about this board. Now with my automation software, it essentially doesn't matter. There are block sensors at the ends on the board below this. So a train rumbles through, it triggers those, I can stop it. There is block detection back here before it comes in. What's missing is this bit in the middle, and that's what I'm going to address today. I've put together a pair of these things. We're going to have a little look at these in a sec close up. These are MERG DTC2 current sensing block detection. I've printed a few brackets for them. And this is in two stages. The first stage is fitting and wiring these in. You don't need a microcontroller to use these things. You could use these as they are to feed LEDs on a panel. So the first thing I'm going to do is I'm going to fit these, I'm going to wire them in. And we'll have a little talk about what they do and how they work. Let's have a look. This is Leopard Street. Okay, block detection board. These are the kits from MERG, Model Engineering Railway Group, I believe it is. DTC2, not DTC stands for, but this is kit 50, so you've got to be part of MERG to get hold of these things. What do you get? Let's have a little look. You get a rather nice piece of yellow card, which has some components stuck to the back of it. Sometimes these come in a bag. Here they're stuck to the back, so it tells you what you've got. 22k resistors, 470k resistors, 1k resistors, 2.2 nanofarad capacitors, 100 nanofarad capacitors, 2.2 nanofarad tantalums, 10 microfarad tantalums, 1N4148 diodes, a Schottky rectifier diode, a couple of LEDs, and some transistors. I think it's the 8 where they all come in the bag. Circuit board, we're going to build it all on. Some instructions, which are surprisingly good. A lot of modern instructions are rubbish. These aren't. This tells you where to put stuff. Also tells you what order to put it in. And it's got some stuff on the back. There's a circuit diagram. We'll have a look at that in a bit. And go over there, and then in here there's a few more bits in a bag. I like things in bags. Bags are good. So what do we got? We have a 556 timer circuit. If you've seen the 555 timer circuit, that's two of them in one chip. That's all that is. It's literally just two of them. Common power and ground, and that's your lot. There are a couple of screw terminals which take wires. I think they'll take ferrules as well. I think they'll take small ferrules, if I remember rightly. These are the magic beasties. These are current transducers. So this is a transformer coil. You wrap another bit of wire around there, and when you pass a current through that, it will transduce and generate a current in there. There's some wire to use with those. I don't use that. You can use it. It's enamelled wire. I don't. I prefer to use the 1602 I use for everything else. I have a plug and socket and some crimps. This is one thing to be aware of. If you get one of these kits, you need a crimping tool. The one I use, I'll bring out from over here where it's hiding, if I can disentangle it from everything that it's tried to wrap itself around with, is one of these, an iWiz. I get them on eBay. It'll do these, and it'll do the DuPont style connectors as well. These are, what are these things called? These are JYK crimp terminals. So these are the JST style These are JYKs. They're a little bit bigger than the normal JST connectors, slightly annoyingly. Yeah, pin spacing is a little bit, so yeah, they'll go in there. When I did this my N-gauge layout, I didn't use these. What I did is I put a 4-terminal screw connector on there, and you put power, ground, and you get the 2 signals out. That's the only connection you need. The rails connectors are at this side, so that all comes later. Now, actually building one of these is comparatively straightforward. It involves soldering things. Now, soldering is... it's not a hard activity. There's a bit of a knack to it. If you're going to do anything on model railway, it is well worth learning. I'm going to get this built. I'm going to go into fast forward mode. I'm going to cut the audio and I'll do a little bit of a voiceover and go through what this is and how it works while I'm building it. So, let's go on with it. Yes, okay, we'll leave the half-wit in the cellar working away. So while we're doing that, let's have a look at what this circuit actually does. Now this is the circuit diagram. I've modified this to be a single detector using a 555 instead of the twin 556, but there we go. Bit off to the left with a circle, that's the current transducer. There's various capacitors, resistors, diodes, a transistor, and then a 555 timer. What this does, this is set up the output goes low when it detects a train, which means the little LED will come on because it'll conduct from 5 volts. The discharge pin also goes low at that point. We'll have a little look at how 555 works as well. So here's the 555 timer. Handy little gizmo. Gets its name from the 3 5K resistors that go between the ground pin and the supply pin. Other pins quickly. There's a trigger pin. Now if this is in a low state, and by low I mean a third of the supply voltage or less, the output of the chip goes high. It has been triggered. The output is what gets triggered. This is the output of the flip-flop. We have a reset pin. Now if you set this to ground, you will reset the flip-flop, so the output state will go back to low. There is a control pin, which can be used to control where the voltage threshold sets. There is a threshold pin. Now if this goes above 2/3 of the supply voltage, this resets the SR flip-flop again. There's a discharge pin, which is an open collector. This goes in via the little transistor. So if the output is in a high state, that pin is connected to ground. That's where we connect the sensor. The output pin is our little LED. That's basically the chip. I'll cover that in a little bit more detail in another video. Okay, so here's the circuit in a slightly different way. The output node here goes to both the trigger and the threshold pin. As per the first little circuit, they're connected together. So what we've got is a situation here where if the voltage on the output goes above the threshold, which remember is 2/3 of our supply voltage, the detector will go high. This is what the output of the 555, which is our detector circuit, will go high. And it'll stay high until that voltage at the output point drops below 1/3 of the supply voltage. So what we're going to do, we're going to power this thing on initially. I'm going to turn the power on at time equals 1 second. And that'll allow us to model the little initial period. At a time equals 5 seconds, I'm going to send a pulse in from our little current detector. We found a train, and it's going to stay there for 5 seconds, and then it's going to go off. That's what the switches are. I just set the thing up to model it. So the simple thing to do is you've got to realise is that capacitor will charge, capacitor C1 will charge through resistor 1 very quickly. It's 0.05 of a second it'll take roughly. You'll see it in a minute. That's how long that takes to charge. And it then starts to discharge through the remaining circuit. Basically, the voltage at the output point will jump up high and it will then gradually decay. Because that capacitor will charge to start with and then it will start discharging. And when it drops below the trigger voltage, the detector will go, yeah, I'm going off. And it'll stay in that state. As that capacitor carries on discharging, it'll take it a while to fully discharge, but it's below the 1/3, so we're fine with that. And it's discharging through resistor 2 470k. Now, the time constant there is about 1 point something seconds, and that's the time to drop by 2/3. So, as we'll see in a minute, that's about what we've got. So, let's power it up and have a little look. And this is the best bit of using Circuit Lab. It'll do this for you. Now, what we've got here is an input voltage, which is the blue line. And at time equals 1 second, that jumps to be 5 volts. And it takes it a very little amount of time to do that. And the brownish coloured line is the voltage that is going into our 555. And I've labelled the two trigger voltages. Down at the bottom we've got a red line, which is what the detector output is doing, and we've got a little purple line that says, is there a train there, yes or no? Because initially there isn't, that's just a startup pulse. So as you can see, initially the brown line shoots up to about where it's going to get to, which is over the threshold, and then our detector output says, I need to go high, so it goes high. That then starts to decay. Basically it's no longer charging, and it drops off. And when it goes below the trigger voltage, the output switches off, and now it's in a steady state. It'll just stay there. Then we come along, and at 5 seconds our train appears. Ta-da! That generates a pulse of current. This switches on the transistor, which bypasses that basically then triggers the big capacitor to start discharging. And we've got the pulse, so that stays up. And the thing is to notice, whenever the train is there, that pulse will remain. So it's constantly setting that up. That holds the input voltage above the threshold, so the detector says, yeah, there's a train here. And the train disappears at 10 seconds. And again, that capacitor discharges. And it takes it a little over a second to fully discharge. The beauty of this is, if that train present circuit goes on, off, on, off, on, off. Say you've got a bit of an intermittent contact. This system will trigger, and it will always hold the signal for about a second and a bit. It's about 1.1 seconds. Which is actually quite useful. Basically, it debounces the output for you in a wonderful little way. And it's the genius of how this circuit works. It's using the timer circuit with its internal comparators to provide that little bit of hysteresis and that little bit of a delay. So, with that, let's get back to the Burke in the cellar and see how well he's getting on building these things. Okay, that is a DTC2 assembled. Let's move my light back around the other side again. See what we're doing. Doesn't take very long. It's a bit of a knack. As you noticed, the instructions say, of the current transformers, you solder these in and then you feed the wires through. It's a lot easier to do it the way I did it, which is solder one end of a wire, wrap it round, just seal the other end, push that through the hole, solder that in, and then solder this. If the wires don't go in properly, or you end up cutting them too short, you've not soldered these in, so you can just take it off, take the wire out, and start again. But that's finished. It needs the chip putting in. There is a test step. I don't do it. I've built enough of these, I know they're going to work, so I'm not too fussed with it. So that goes into there. And what I've got left is 2 resistors. You can, I might have mentioned it on the voiceover, but these here, I've put them in as wire links. These go to the output terminals. You can just see the wire, it comes up here. Now, you can, if you put those resistors in, 2 1K resistors, connect the output pins to LEDs. So if you want to put this on a panel somewhere, all you care about is there something in a block? I want a little indicator light to tell me there is. Away you go. Personally, if that's all you want, I would be very tempted to put a socket where this LED is and put some wires off that to an LED, and then you've always got this if you want to use it for something else. But that is that. Now, what I need to do is find the connector, because I'm going to put that back in a bag. Essentially, I'm going to do 4 of these. I'm going to do all the connectors at once. I do those bits when I come to wire them up. So that is one of these. Didn't take very long to build. I've got 3 more to do, so I'm going to do that off camera. and then we'll be back to have a look at them. So I'll catch you in a minute. Okay, here we are, the nerve centre of board I. This had a temporary installation done. So what we've got here, these brown wires are the 3 blocks. Yeah, there's one goes to it. These 3 are feeds that way, there's feeds in the middle and there's feeds over at the end. And they're currently all commoned together. Now the first thing I need to do is remove that. Because, loose wire. All good stuff. Right. They are no longer going to be commoned together. So I need to take this rail off the bottom. This is the first job. So that comes out. I come over to this side here. I'm going to remove the other end of that wire. That's no longer needed. That's basically scrap, so I'm going to get rid of that. The next job is to install these little beasties. Now, these are DTC2 block detectors from MERG, and this 3D print mount actually comes from MERG as well. You can download the file. I've added those 2 screw holes. They just come with 4 little ones. What we've got on here, the camera here, see if that focuses. Yeah, anyway, that's where the logic and power comes in. These here are the feeds for the track. I just realised I'd forgotten to get a set of screwdrivers I'm going to need for that, but I'll do that in a minute. The first thing I need to do, though, is mount them. So I'm going to take a few screws out up here, out of the way. And I've got these 2. Now I can put these either way around. They're square. But what I'm going to do is put one there and the other one above it. And then I can take the feed from here into that, into the one above. 3 wires can come out and they're going to go over to this terminal here. So that's the first thing to do. I'm going to fit these first. Basically because I have to. When I design these things, I tend to make it so the screw hole is accessible from above. These aren't. So you have to fit these before you mount the board on top of them. It's not really a problem, but they're going to go in there. Now, normally when I set a board up, I'd already have these. When I built board I didn't have them, so I couldn't. Otherwise, I would have. Right, that's then going to go. It's a bit awkward to fit and hold, actually. Right, I don't want it actually touching the other one, but I want it near it. But because you don't actually need the logic controller to make these things work, what I did on the other boards is I wired up the bigger versions of these. I've been using DTC8s for the main part. And what I did is I wired them all up in place. Didn't power the board up. There's no power to the boards. They're just there. But it meant I could wire all the block wiring through them. This is something I haven't done with the new station boards, which I'm actually starting to regret. I'm starting to wish I'd actually done that, just because it does make life a little bit easier. But then these can come over here, whichever hole is the easiest one to put a screw in. They come with 4. You know how to put a screw in. When you're doing this sort of thing is put them all in loose, then tighten them all up, because that way everything lines up. Now these little boards have LEDs on them, and when we power this up, which I'm going to do in a few minutes, although I'm going to get all the track wiring done first, the lights will come on, and it gives, it's a bit of a self-test, but it also means you can actually use that as block detection. We'll have a little look at the boards in a minute. I built these, this is Saturday, sorry, this is Sunday. I built these boards on Saturday afternoon, and we're going to jump to that if we haven't already jumped to that. I'm not quite sure what order I'm doing this video in. Yeah, it's organisation for you. But anyway. Yeah, this board's only got 3 sensors, or 3 blocks, so I didn't see the point in the big DTC8, so I thought I'll just put a pair of these in. So there we go. That's that one, that one, that one, and that one. They're mounted. That leaves this space here for where the board controller is going to go. Sorry for the lighting. I don't really have much of a light down here. This wire is a common wire, and it can stay as a common wire. I might even actually try and clip that to something in a bit. So I now need to run 3 from here into 3 of those. So I need to go and find the other screwdrivers. So I'll be back in a sec. Okay, back with screwdrivers. So I need, whether these are flat blade or Phillips, I can't remember. And they're open to start with, which is good. So what I now need to do is find out what size ferrule fits into them. If I remember rightly, it's the white ones. They're the Diddy ones. So if one of those fits in there, which it does, that's perfect. Right, so now link these into these here and here and here. So that works. So I need some wire. And what I'm going to do is get myself a decent length of this, just because it's a little bit awkward working down here. So I'm going to do this. As usual, crimp on one end, because it's a single wire, a bit longer than usual, and double it round on itself. There we go. A bag of crimps, which I get from GWR Fasteners on eBay. Who supply this stuff at not unreasonable prices and with pretty quick delivery. So more than happy to keep using them. Spin that round and then crimp that. A little bit of a test, try and tug that. Now this is going to go into this one and is going to come up into there. Doesn't matter which way round you put these terminals, which is always good. Because essentially what you're doing, if you look at the brown wire on here, it basically goes in, goes around a few loops and comes back out again. The board itself uses magnets, well, electromagnetic field. It's basically a transformer. Referred to as a current transducer. Sorry for the bald head. Bend down to pick up some other bits and pieces. Yeah, the purpose of all this is to get this board onto my block detection system. I'm going to go with the inner terminal is going to be the feed to the track. Again, it doesn't really, get a screwdriver. It doesn't really matter. You know, so you can do it either way. It's just, it's one of these things. Sometimes it's useful to, nope, do want the small one. Yeah. As long as it grips it, it's fine. Right, that's into there. That's going to turn around and go into that one. So yeah, that's one. Right, where'd that bit of brown wire go? Get the next bit. But yeah, these are fairly straightforward. So if you wire these in as you're going, I mean, you do have to decide how many blocks you're going to have, where they're going to be, what sort of blocks they're going to be, and all that sort of stuff. As you go. This board, it's remarkably simple. There are 3 blocks on it. It's just literally 3 pieces of straight track. So, yeah. Going to have to crimp that a bit more. If I'd have had these, I would have done it, but I didn't, so I didn't. So I'm doing it now. This is part of, like I say, I want to get... There's 2 jobs I need to do on the lower deck. This is one of them. The other is actually another part of the reversing loops, also needs block detection going in. And the reason I want it on all of it is because if I put this on all of it, yeah, that's to there, what I can then do is set JMRI up to not only tell me where trains are, but what the train is, which is something I want to play around with. So by that, I mean, there's no train identification on the layout yet. There will be, but there isn't yet. So I would have to tell it that, say, the internal track on here, or the external, whichever, is the Flying Scotsman. JMRI is then capable of following that around the layout. So I'm getting a cramp in my foot, which is, I might have to stop this in a minute. Come on, open up. Right, that's in there. Right, I'm kneeling on the floor doing this, and it's not particularly comfortable. Right. Also help if things would stay where they were put. Right, that's that one. I've got one more to do. I'm going to stand up while I do bits of this. I'll be back in a second. We'll put the other ones in. Right, okay. These 3 wires over here are in now to do this. So I've got 2 of these. I've got a twin one and somewhere a single cable, because I only need 3. And they're going to go back to back into this over here. So I'm going to back this off a little bit more. So I'm going to put these in here. So I need single one in first, get it the right way around. Screwdriver down, because I'm going to need 2 hands to do this. Always need 2 hands to do it in the end. That can go into there. Excuse my arms getting in the way here. There really isn't a lot of space down here. Right, that's that. Now these are going to get routed around the top and into these. So what I'm actually going to do is get some tie wraps. I want to do that before I connect them at the other end. Of course, that way it's all a bit easier. And I'm actually going to, the blue cable isn't long enough to do it with. I thought it might be, but it's not. So I'm going to bundle these up here with the other brown wires. Into there like so. Going over there like that. I'm going to pull them back a little bit because I want a bit of slack on that. I'm going to tie these over here. Now I've actually got a cable clip up here that I'm not using, which I'm about to rectify and start using. Oh, I see why I'm not using that. Yes. It's a little bit awkward to use. Right, never mind. I can do that. Bring these across here. And this is all about keeping the central area of this board free for the controller connections which are coming up. There we go. And then these wires come around here. Some of them are a little bit long. I'm actually not that bothered by these having a little bit of extra length to them. Because it doesn't matter. In a very deep and meaningful way, it really doesn't matter. So, back that one out. Get in there. And with these wires in, I can actually run trains again. These boards won't do anything, however. These are a little bit long. No, never mind. And obviously I'm not going to use the top one. However, I'm not going to run trains just yet. What I want to do, let's put that back on here so these are covered. What I want to do is power these boards up. To do that, I need to give them a power connection. Now, there's 2 ways of doing that. One is connect them to the little PCF board, which is going to sit around here, and then the controller's going here. I might end up replacing that because it might be in the way. But what I'm actually going to do is run power and ground to over here directly. So I'm going to have to cut some wires to the right length, which means getting hold of some wire. Here I have some wire. Fancy that, some wire. So these again are going to run over to the top, so it's going to come over there, over to here, down to about there. Add a little bit of slack to it. That's one. The other needs to be a bit shorter because the other one is going to the wire at the top. So that's going to come along here. It's going to come down to about there. So that's my two red wires. I need to make two black wires the same length. Now, you can power these boards on lower voltages. I'm going to run it on 5 volts because they're 555 timers. However, I'm going to stand up to cut this because it'll be more convenient and more comfortable. Because they're 555 timers, you can run them on higher voltages because they're quite good like that. Although they do insist on it being DC voltage. So let's bring you back up here. Angle down a little. So yes. Yeah. I've got to clear a lot of this crud off here now as well. Need that. Don't need that. I'm gonna have the terminal for this is a little bit different. This is a crimp terminal, which I'm gonna have to go back to the desk to do. I'll leave the screws over here because I'm going to need some more of those. Actually, no, I'm not. I'm going to do this in 2 stages. I'm going to get this board hooked up so that those red LEDs can light, because this is a basic test. It also allows me to do something that at the moment I can't do, which is work out which of those terminals is for which rail. I didn't mark it when I did them originally, and I don't know. So I'm going to have to do that. Need to clean this off. And again, this is a couple of bits. I'm going to make one end of this loom, and then I'm going to make the other end of it. Then I'm going to cut the ground cables the same. And I'll be back in a minute when I've got this done and we're wired in. Yeah, back. I have a wiring loom. It's a fairly basic one, but never mind. Right, so this can go into here. Now this is also going to need more wires going into it in a bit, because I'm going to have to power the actual controller from over here as well. But for now I'm not bothered. So ground and logic 5 volts. Because this is a logic circuit, not a power circuit. And if you're thinking I should have held off having those up until this was in, you are of course entirely correct. Right, that goes that way round. And it goes onto the connector properly. That one comes down here, goes onto that connector properly. Right, now, big test. These lights should come on. Whee! Got power to those. So the next thing to do is a bit more testing. Now, I'm not going to use a locomotive. I'm going to grab a coach. And the reason I'm going to grab a coach is it's easier to roll around. I might grab a loco and I'll just position it manually. I'll be back in a minute. Okay. Victim of the day, Cheshire, sitting on the innermost track. I've got a red light on. Lift her off, goes out, put her back down, comes on again. Now, you will have noted then a slight delay between me lifting her off and the light going out, and that is the magic of these boards. They debounce the signal. Essentially, the timing circuit is set up to run in monostable mode. So there's only one stable state, which is off. And it's set, so when you trigger it, it goes high for, well, the light comes on. It actually goes low, but we'll talk about that later. High for a second. But the loco being here is constantly resetting that. So we take the loco off, it's not being reset anymore. Timer runs for a second, job done. Right, I've got a little job to do, which is to make a note on here. I'll just do it up here so I've got a flat surface under the thing. What I need is 1, 2, and 3. Now, try and get the pen lid back on without covering my face in yes. Right, so the inner track is track 3. So what I'm going to do is take that sticker. I'm going to come down here. It's a little bit awkward because space is a bit confined. I'm going to put it on that coil. So there we are. That's track 3. Now what I'm now going to do is put it on the middle track, which is quite useful. It's actually gone the way I'd hoped. I was hoping it would be 1, 2, 3 or 1, 2, 3. So that is track number 2. So I'll mirror that up, and then I'll put the thing on the other one. So another sticker. You don't need to label these. It's just sometimes it can help with debugging. Right, the other one should be track number 1. Which is the outer track. And it is. Excellent. Now that is the first stage of block detection done. So I'll just get my finger around the thing. So what we got now is when the track power is on, I can see if these blocks are occupied by coming down here and looking at these little red LEDs. Now, as you can probably imagine, that's not actually terribly useful. So the next step is going to be to put, the next step is to put a little PCF 8575 in, but also the board controller. So what we're going to do now is we're going to go back to the desk, and I'm going to have a little look at the board controller, and we're going to start looking at its software because I've got to configure it. So we're going to have a look at that. Right. So with that, this board now has a pair of DTC2s connected. They are correctly identified against the tracks, and they are picking up trains sitting on them. That's going to be it for this episode, just the length of the thing. In the next one, we're going to look at connecting them from just being the bare modules to connecting and talking to the rest of the layout. I'm going to be putting in a board controller, a little interface board. We're going to have a look at the software. We're going to configure it. We're going to add it to JMRI. And we're going to test it. So, that's the next one. Hope you found this one at least not too tedious. It's tidying up jobs. It is something that needed doing. Anyway, with that, enjoy the rest of your week. This has been Leopard Street. Thank you very much, and goodbye.